This is an introductory session to the Microsoft Assembler or the MASM. So you will be using the MASM program, MASM application as the assembler, and you will be using the debug program or the debug application as the debugger in your lab. So MASM would be your assembler. In the lab, we will be using MASM 6.11 version, which is the latest standalone version of the assembler provided by the Microsoft. So the MASM 611 folder would be made available to you. Make sure that all the programs which you are writing, that is the assembly language program or the .asm programs, are within the bin folder. Okay, so the assembly program should be within the bin folder itself. Now, as I told you, the debugger which you would be using is the debugX. So what you can do is, you are already provided with the debugX application. You can copy the debugX application into the MASM bin folder. Okay, so MASM would be the assembler and the debugX would be the debugger. Now let's start our DOS box. We'll start with mounting the particular drive, so you can use the command mount. I'll browse to the location where I have my MASM folder present. I am browsing to the location bin folder. Now the program should be written within the bin folder itself. So your .asm file should be within the bin. You can create your own ASM file. You can just start with a text document, for example, and you have to save the text document with the extension .asm. Okay, you can save the file with extension .asm. That is one thing which you have to take care. Either you can do this method or you can use any of the standard editor programs available to create your own ASM file. So just to show how the assembly is done using the MASM program, I'll take a already pre-written example. I'll take an example code which is already available with me, that is the ex1.asm file. Okay, so I have my .asm file already ready. This is a simple code just to illustrate to you how to use the MASM application. So this program just searches for a 32-bit value here in an memory location which I am naming as array. The array will have just 3 data elements. All the elements are 32-bit. Okay, so this program basically counts the number of occurrences of a data value in a memory location. So by now you would be familiar with the format of writing a assembly language program. You will start with .model. In this case I am using the model tiny. So I use .model tiny. If you are writing a program for a 486 processor or 386 processor, you should provide the appropriate director. In this case I am writing a program, say for example a 486 processor. So I use the directive .486. Then I start with the declaration of the data segment, that is the .data, followed by the declarations or the data declarations. So in this case I am assuming that the array is already defined. So I have an array named as array. The data values are declared here. All are represented as 32-bit values. Remember, when you use MASM takes the data value by default in decimal numbers. So if you want to provide a hexadecimal value as input, you have to provide it explicitly. For example, I am giving all these values in hexadecimal format, so I am using the H here. Okay, so by default, MASM takes all the data values as in decimal format. Now, number of elements, I have stored it it's not stored in the data memory location because I'm using an EQU construct. I'm just representing the number of elements in the array as count. The code 1 is the data value which I have to search in the particular array, and the number of occurrence of the data value would be stored in a memory location called as result. So after the data declaration, and I'll go in with the code segment declaration, the command would be .code. Then I'll be using the .startup command. So after that, you write your program and finish your program with the .exit and end statements. So I think the program is pretty easy. You might be able to understand it by now. Okay. So I have loaded the initial address of the array in my SI register. I have loaded the number of counts in the array in my CL register. I am moving the first contents of the array into the EAX register. I am searching for a 32-bit value. So I am moving the value into a 32-bit register. I am comparing the contents of the first location with the defined data value. If it is not matching, I have to start comparing with the next memory location. That is, I'll increase the SI value by 4, decrement the count, repeat the whole procedure. Whereas if the contents of EAX and the code matches, I'll increment the result location. So the program is simple. Okay, so we'll try to see how we can assemble this program using the MASM. Okay, so to assemble the program, you have to use the command ML. There are different ways of assembling. I'll show the first method now. The first method would be using the ML command. So before executing this command, make sure that you are executing this from within the bin folder. Okay, so to browse to the correct location, then use ML. ML is the command for getting the executable file. So ML followed by the file name. My file name here is ex1.asm. Okay, so now you can see that you have got an executable. The executable name is ex1.com. So here I have used a tiny model in the program. So I'll get an executable of the format .com. Okay. So I have assembled the program using the MASM. Now if I want to debug it, I'll be using the debugx. So for that purpose, we have already copied the debugx application onto the bin folder. So now I can debug it. I can debug the program using the command debugx followed by provide the executable file name. In this case, it would be ex1.com. Okay. So now you are running the debug application and you can do the debugging of the program. Let's first you see the program using the U command. So when I use the U command, you can see the program which I have typed in here along with an assembly. Okay, you can view the register contents here. You can see that I have used the tiny model. So all the segment registers are pointing to the same value and IP is pointing to 0100 since it is tiny model. Okay. CX would by default, if you load the program using debugx file name, the CX will have the count and the count will represent the number of bytes occupied by your code and the data. Okay, so now if you look at the U command, I'll just type the U. You can see that first you have the instructions which you have typed in. Say let me use U100. You can see that you have the instructions which you have typed in. The .exit and .exit and end gets converted into these two instructions. Move at AH, 4C, int 21 respectively. I'll just type view again. So I'll be able to view the next instructions. So you can see that here these are the data values which I have stored into the memory location. Okay, so this is tiny model. Your code and the data segment starting address is the same. So when the program gets loaded onto the memory, you will initially have your program followed by the data declared. Okay, so you have data declared till this particular location, and that is the value which was present in CX. The CX register will have the total number of bytes which taken by your code segment and the data declarations. Okay, so you can view the program, and let's see how to run the program. You have seen it already when the introductory session of debug was provided. To run the program, you can use the G command. So let me use G followed by, I'll execute till this point, right? Till this particular instruction. So I have to provide the command. I have to first check for the value of IP. The IP is at 100. Then I will provide the ending address for the G command, which would be 011C. Now the result is actually stored in this memory location, which is result. Okay, and you can see that the memory location pointed by result is actually 012C here. So you can view the memory location using the D command, DDS 012C. You can see that the value is 01. So this memory location was supposed to have the number of occurrences of this particular element. So we had one occurrence of 4. So you can see the value is 01. Okay. So now we will make a small change in the program. We will just convert the model to dot model small. So I am making the modification here in the program. So if I have a small model, I have to declare the stack segment also. So I'll go with the default stack segment size, which is 1 KB. So dot stack. The rest of the program remains the same. So now again I can assemble the program using the ML instruction. ML. My file name is ex1.asm. Now you can notice that the executable is in the format of exe. So all the small model programs which are written using the model small would be converted into .exe file. You can again view the program. You can again debug the program using the debug x command. So debug x ex1.exe. So there is a slight difference between how you should debug a program written using .model tiny and .model small. Okay, so here the executable is in the format .exe. If you use the command u, you can see that you have certain instructions here which are meant for the stack segment and the stack pointer initialization. Okay, your actual instructions comes after those instructions. So these instructions which you see here are actually for the initialization of the stack segment and stack pointer. So you have to also execute these particular instructions before you execute your actual program. Okay, so you can execute your program. Say now if you type G010, the IP points to 0010, where you have your actual program written. Then you can again, if I type in U, I can see that the program which I have written is still this location, that is 002C. So I can use the command G002C to execute the instructions. Okay. So the only difference would be that when you load the program, the .exe program, you will have certain set of instructions which are meant for the stack segment and stack pointer initialization. You have to execute those instructions also before you execute the instructions written by. Okay, so this is how you can assemble the instructions written, and then you can use the debug program to debug your program. Now there is another alternate method for generating the executable. For that you can use another command. Let me just quit from the console. You can use another command which is masm. So if you are following this procedure, you will get the executable in actually 2 steps. Okay, so we will see how this can be done. So the first command would be masm followed by the file name. So here it is ex1.asm. Okay, so the output of this command, that is masm, would be an object file. Now you will have to use another command to link the object file and obtain a final executable file. So use the command link followed by your file name .obj. Okay, so once you link, you get the final executable. So you can either leave the run file, that is the output file, with the default name. So you can just press enter. So you will get the default file names. Okay, so by this you are getting the executable in actually 2 steps. You first use the masm command, then use the link command. So now the final executable is of the format ex1.exe, which you can debug. Now, so we have seen 2 different ways of obtaining the executable file. One was using the ml command. The second procedure was using the masm command first, followed by the link command. Okay, so this was an introductory session on how to use the masm assembler along with your debug X debugger program. So I'll wind up the session with